Welcome to our Azure Incident Retrospective. I'm David Steele.
I'm Sami Kuba. We work in the Azure Communications team.
In addition to providing a written post-incident review after major outages, we also now host these retrospective conversations.
You're about to watch a recording of a live stream where we invited impacted customers through Azure Service Health to join our panel of experts in a live Q&A.
We had a conversation about reliability as a shared responsibility, so this includes our learnings at Microsoft, as well as guidance for customers and partners to be more resilient.
We hope you enjoy the conversation that follows. But for today's focus incident, we are going to talk about two related incidents. First and foremost, we'll be discussing the Azure Front Door incident. And now this was triggered by some erroneous metadata that was generated as a result of a bug in a new version of our control plane that we were rolling out. Now, this lasted about 8 hours, but it was followed very quickly by a related Azure Portal incident. Just a few hours later, the Azure Portal failed back from when they failed away from AFD. And so this is going to be the part that we're going to be talking about today.
That's right. So to talk us through that incident from the 9th, I'd love to introduce the engineering leaders joining us on our panel here today. To my left, we have Varun Chawla. Varun is our Partner Group Engineering Manager representing Azure Front Door. And on the end here, we have Ruhi Mahalati, who's our Vice President and Engineering Manager representing the Azure Portal side. So thank you both for joining us today. Varun, I wonder if we could start with you. Sami, what do you think?
Yeah, but before we get into the actual incident itself, many customers don't use AFD, many customers do use AFD, but AFD was a key ingredient here. Before we talk about anything, could you talk us through what AFD is, why customers use it, how customers use it?
So essentially, Azure Front Door is the global entry point for a lot of Microsoft services as well as our customers. Customers use AFD for accelerating their content delivery, for doing global load balancing, and for security with WAF and DDoS protection. We have a bunch of customers in the third-party world, but we have a bunch of customers in our Microsoft services like Azure Portal, which also use Azure Front Door for both security and acceleration.
Yeah, just to add to what Varun just said, Azure Portal heavily uses Front Door, and it really benefits us in many cases. We have a lot of static content in Azure Portal, so we benefit from the content caching capabilities, as well as the scalability and the resiliency of being able to remove an origin server at any time, reroute traffic, but also the DDoS and the WAF protection. Those have been really, really valuable, and we've been benefiting from all of those benefits from leveraging AFD as the front door for Azure Portal.
That's great to understand. So Varun, I know there are some customers who know that they are customers of AFD. They choose to use Azure Front Door, and other customers who may not know that explicitly, but AFD is behind a lot of the services that they are using.
Yes, that's correct. Just like Azure Portal, there are a bunch of other portals which also either directly use AFD or have a dependency on Azure Portal, and hence they use AFD. There's a bunch of Microsoft critical services which are also on AFD. In this case, there was impact which was more broader. So some customers might not have realized that they are impacted because of the AFD outage because another Microsoft service was impacted.
Right. That dependency tree is always interesting to understand. So before we get to the trigger event of this incident, we want to talk a little bit because the post-incident review mentioned this update to the Azure Front Door control plane. So can you talk us through how do we usually apply updates here? We talk in these sessions a lot about safe deployment and how we do rollouts carefully, but what should have happened? How do we usually roll out updates here?
So there are two things that happened prior to the incident. One was around 6 weeks earlier, we had rolled out a new version of the control plane. And the way that the control plane is deployed, we follow safe deployment practices where we first deploy to test, make sure all our validations pass. We deploy to a staging environment, canary environment. Then we go to the low traffic environments and high traffic environments. So all of this is done with bake time, with signals which are being automatically monitored, with automated rollback if the signals indicate an issue. So this is the first rollout that happened around 6 weeks prior. And then between the incident and the time that the new control plane version was deployed, we were onboarding a very small subset of customers onto this new control plane. I would say less than 1% of the customer operations were onboarded. The customer, just the update operation, gets is obviously different. Less than 1% of those operations were onboarded, and only the create operation. So only if you create a new profile, that's what's going through the new control plane. Any existing profile, any updates to it, delete to it, that was not going through this new control plane.
So for that first 6 weeks, we hadn't had health signals that there was anything wrong, that everything was working well. We were just starting to flight it and add more customer operations.
That's fascinating. And so we do this very gradually, and it's interesting. But what we were saying is that when this happened, customers ran a sequence of operations which unearthed the bug.
Yep.
Now, our system, did it handle it well? Did it not handle it well? Like, did everything, because it's a small number of customers.
Yeah. And customers were using AFD correctly, right? It wasn't like customers had made a mistake.
There was
profile of.
Yeah. So there was no fault of the customer. They were doing the expected series of operation. It's just that in a particular sequence of like 5 different operations with certain configuration, it triggered a situation where our control plane generated this erroneous metadata. And once the customer makes a change, we deploy the customer configuration along with the metadata to all of our edges. And in this case, that erroneous metadata was causing a crash in our data plane.
Right.
Now, the way that it works is we have staging of our customer configuration deployment as well, just like we do staging of code deployment. The config first goes to a canary stage, or let's say stage 1. And in that stage, if we identify any issue, then we automatically block the config from proceeding to the broader stage, which takes most of the traffic in this case.
What happened this time, right? I
Yes.
was reading in the post-incident review that our automated protection saw that there was an issue there and at least initially prevented impact. So what went right?
Yeah, so we did detect that there were crashes happening in the data plane in the first stage of deployment. And in that stage of deployment, the protection system detected that there's an issue. So we blocked the config from rolling to the next stage. In addition, when there are crashes in the data plane, the traffic, the WIP is all automatically withdrawn so that the traffic no longer is sent to the unhealthy ones. So all the customer traffic starts getting sent to the healthy edges, and there's no customer impact.
So that's all great.
Yeah.
And then it was the next day, or it was afterwards, where we said we're going to perform a cleanup operation.
Yes.
Now, when we perform the cleanup operation, we remove these protection systems. Is that the right way to think about it in order to do the cleanup?
Yeah. So in this case, the customer configuration with the erroneous metadata was still in the system. And the engineers took the call that there is a risk of having that metadata in the system, and we want to do the cleanup. Now, the initial issue was triggered by the config update with a specific series of operation. And at this point, because our protection system was blocking any updates for that customer, the engineers had to bypass that system and move on to the next stage. And then this delete operation, which did the cleanup of both the metadata and the configuration, now it went to the next stage, which has a much larger blast radius. And that's where, unfortunately, the delete operation also triggered the same issue, where we caused crashes in the next stage, taking down around 20% of our global capacity, primarily in Europe and Africa. That's where most of the impact was concentrated. There was some impact in APAC and Middle East, but it was much smaller than what we saw in Europe and Africa.
Got it. That's good to understand here. So our hands were tied because of the protection system, and we said we want to go in and clean it up, and it was actually removing that blocker that let it propagate through the system. Okay. So once it had propagated into the system, what did that impact look or feel like for customers?
Yep.
What were the errors or symptoms that customers would have experienced? Was that persistent? Was it widespread? Was it some services, some regions? What would that pain have felt like for customers and partners?
So for the first 5 hours of the incident, there was some availability impact to the customers. The peak availability impact was around 17% in Africa, 6% in Europe, and around 2.7% in APAC and Middle East.
So the majority of operations were succeeding. We got as low as 17% failure rate?
Yeah. So now when I say availability impact, that means their requests for failing. They were timing out in most cases. However, one of the things that we had to do, because 20% of our capacity is gone, we need, and specifically because the concentration in Europe and Africa is more, we need to be able to reroute the traffic to the healthy edge sites. Now that meant that overall we were running overloaded throughout Europe and Africa. That means that the customers do face elevated latencies as well. And one of the things that we have to do to be able to spread the traffic around is you are serving traffic from an edge site which is not closest to you. Right, so because your edge site, your traffic is being served from an edge site farther away, you do have that additional latency. So for the first 5 hours, after we fully mitigated the availability impact, we were still moving the traffic around to make sure that we are able to serve it from the healthy sites while the other sites become healthy. So the latency impact was there 3 hours beyond that as well. So that's why the total impact time is around 8 hours.
Going back a little bit before when this happened, how did we detect this? How do we investigate an issue like this? And then ultimately, I'd love to know how do we mitigate?
Yeah. So in terms of detection, the issue was automatically detected. We detected it, I believe, within 15 minutes or so. And the key element here was that there are multiple ways that the system can crash. We have our data plane, which has multiple forks of the process, and they are the ones which serve the customer traffic. let's say one of those forks dies, we'll come back up within seconds. If the main process, main data plane process goes down, then if it crashes, we have a config which the data plane has to use. If we are able to use the configuration cache, then we can come back up within 90 minutes. But the worst case scenario is the cache also gets corrupted. And now it takes us around 3 to 4 hours to come up because we have to process the entire config of like around 500,000 tenants. So in this situation, in this bug, we ran into the last category where our recovery time was huge. So over that period of recoveries, in some cases, we were trying to do manual recovery to move a little bit faster and mitigate the impact as soon as possible. But the tail end is something that did last throughout the impact duration.
Yeah, that's good to understand that long tail recovery, and we'll touch in our learnings and repairs on some of the things we're doing to try to shorten that. Ruhi, this is probably a good opportunity to bring you in here because during some of these issues, the Azure Portal saw that AFD was having a problem and wanted to fail away from that. So could you talk us through the BCDR decision that Portal made and what went wrong after that?
Sounds good. Yes. So as part of our standard monitoring, as Varun also mentioned for AFD, they had monitors. We have both internal monitors and outside-in monitoring. So fairly quickly, within minutes, we were alerted that there is an issue which is impacting portal availability when the AFD incident started. So as part of our standard business procedures, we implemented the fail away from AFD. As part of that, we run our automated scripts. So there are two stages of it. One is we make sure that we can fail away, but before we fail away, we have to scale up our origin servers because now we don't have the benefit of AFD in terms of the content caching and things. So we need to make sure. But these are standard procedures. We have implemented these before and we have tested these. So we were able to execute it fairly quickly and we were mitigated much before AFD had the mitigation done.
Great. So the failover worked great.
Failover worked, yes.
As we start talking about the automation scripts and potentially the failback, when we were failing back into AFD are now healthy. How did the scripts work? What should have happened and what didn't happen or what went wrong?
Yes. So that's when even though the scripts executed perfectly well, and maybe there is a diagram if we can show at a very high level, maybe this will help to show how the portal is leveraging AFD. We have two different things in the back end. One is the portal servers, as well as we have the content hosting. So Azure Portal serves content from many different partner teams within Azure itself, right? So I'll focus more on the content hosting side because we did have the failover for both portal servers and content hosting side. They're both behind Traffic Manager and AFD. But the impact really happened on the content hosting side. Everything went fine from fail away and fail back on the portal server side of things. So the impact that the customers faced was on the content hosting, and this was on the process of failing back. And this really, it did start when we started to go back to AFD, but the issue was really when we had implemented the script to fail away from AFD. Even though we had rerouted the traffic correctly to our origin servers, everything monitoring was where there was, the script was running a version older of the API, and we dropped a flag, which was a needed flag from the AFD perspective to say always serve. And we have two different domains that we do on the content hosting side. Sorry, it's a little bit more details, but this will also share the complexity of the system that we work with. And this is where the scripts are important, but there was also some missteps that I'll get to Sammy in a second. On the content hosting side, we have our portal servers. We have two different profiles. One is a server-side profile and one is a customer-side profile. So the server-side profile is when the portal servers talk to the content service to get the metadata and information on the different extensions or partner code that we need to load. And then we have the client side, which is the client browsers connecting to the content hosting to get the JavaScript, the content CSS, and other things. And both of these AFD profiles, very similarly configured and the traffic routing and everything. But when we had that automated script that was ran to fail away, we inadvertently didn't realize, but there was an API mismatch version and a flag to say always serve on AFD was dropped. Everything was still working fine, but what that meant was we had some of our health checks, and only on the portal server profile, the server-side profile, this flag was not set correctly, as well as our health checks were misconfigured. And this meant instead of doing an HTTPS health check, it was doing an HTTP health check. Now, again, this was also in the process of some changes that were happening. So On this specific profile, the flag got dropped and the health checks came back as failed because there was a redirect happening. So when that happened, our AFD endpoint was listed as unhealthy. Now, this triggered when we started going back, what happened was because traffic manager assumed AFD is unhealthy, even though we triggered our automated scripts to fail back to AFD, given that traffic manager was thinking it's unhealthy, it was not directing, and we were blocking non-AFD traffic. Now, this meant, and this is where customers saw the first phase of the impact, where portal was loading, but when you go in the portal, you wouldn't see a lot of the content or extension code wasn't there. So this is where the impact really started for our customers. And this was that misstep in that configuration script that happened. And then we go into the recovery phase when this phase was detected within minutes because we have outside and monitoring that caught this and internal monitors.
Yeah, that's okay. Thank you for painting us a picture of kind of what that looked like internally. As far as what that looked like to customers, as you were just saying there, so the portal wasn't hard down. It was more that the content within the portal was giving people trouble, and this impacted some other management portals as well.
Yes. And throughout the incident, there was about 45% of our customers saw some kind of a failure, right? Either they were not able to load a blade or a view, or the content wasn't showing. So 45% of the customers did see an impact. So this was a pretty significant, and we do apologize for the impact that it caused for our customers. But yes, David, as you call out, the portal infrastructure is also shared by some of our internal partner teams like Intro and Intune from the infrastructure side, as well as the content hosting side of it. So those portals were impacted. They didn't have to do anything different. As we recovered the portal infrastructure, those portals also recovered.
Super. If we could pivot our conversation towards learnings, Varun, I'll start with you. In the PIR, we mentioned some learnings for AFD. One of the learnings that we mentioned is we fixed a bug on the control plane. Now, that you had a lot of repair items, but to touch on a couple, have we fixed the bug in the control plane? Is that not an issue anymore?
Yes, the bug that we had in the control plane, which generated the erroneous metadata, that's fixed. In addition, any other situations where similar erroneous metadata can be generated, that is also addressed. But I think there is always a chance of, let's say, a bad config or bad metadata getting deployed to the edges and causing issues with the data plane. That's why we need a more holistic approach where we are systemically solving this problem. So we are adding more protections in our data plane. So irrespective of what config is sent, it can never bring down our data plane. So I already mentioned that we are already using forks of data plane to serve the customer traffic. So we will be able to use a similar approach for configuration as well, where each data plane server is independently validating the configuration, loading it, making sure that it's accurate, it's not causing a crash, and only then use it to serve the customer traffic. So to solve this class of issues altogether.
Super. And one of the other themes that we touched on is we're going to work on improving our standard operating procedures. We're going to harden validation, more checks. Could you talk us a little bit more through about that? Because it sounds easy to do, but I wonder what implementation looks like.
Yeah. So in this case, the service engineers had to bypass our protection system and go to the next stage, which is something that should not have happened. We should have been able to deploy the configuration without bypassing the system. We should never have a situation where our protections are essentially bypassed. So that's the standard operating procedure that we're trying to update, where we had that capability, but it's something that has not been exercised for multiple years. So the service engineer was not even aware of that. So we are making sure that we altogether first remove the capability in terms of no service engineer will have access to be able to bypass our protections. And we are able to, if we run into situations where things are blocked, we are able to safely maneuver that.
Okay, it's really interesting because I know it's a struggle when how much power and autonomy do you give human beings in a system-driven model that needs to scale. And then lastly, you spoke about thematically the recovery time and how we're going to try and accelerate recovery, because we know outages are inevitable. They shouldn't be broad, they should be isolated, and recovery should happen relatively quickly. What are the steps you're taking in that respect?
So we talked about 3 different categories of crashes, and the last categories where we ran into, we are totally trying to eliminate the last category. So that should never happen. So we should never have a state where the data plane crashes and is not able to reuse the config. We should not need to process the entire config if the data plane crash is happening. So that category totally goes away. Then coming to the second category where there's still the primary data plane which crashes, we want to reduce that from 90 minutes to around 30 minutes. So that's something that we are targeting. And the first repair, which I already mentioned, where we are now trying to process the config in the fork of the data plane. Now, if let's say this bug were to happen again, once we do implement that, then the recovery will be within a few seconds, because even if that fork crashes, we'll have the data planes forks which are serving the customer traffic not impacted, as well as if let's say even if one of those get impacted, they will still come back up within seconds. So we want to go down to within seconds of recovery. And even in the worst case, instead of the 4 hours and 90 minutes, it should go down to 30 minutes.
That's great. So a couple of learnings from AFD about, not getting into a bad space, and then some learnings on even if we do, given that we won't be able to avoid it always, how do we recover more quickly? That's great to understand. Ruhi, similar question for you. Can we talk a little bit about the learnings and repair items from the portal perspective here? That the big one, of course, given that we were talking about this automation script, was how do we handle that better? The post-incident review mentioned maybe some more pre or post checks. What does that look like?
Right. Yes, and I think this is the most important one that we always focus on when we come to the incidents. If you think about the script, if we either had a pre-check which validated is the system in the state that we really expected it to, or the post-check, because the script executed perfectly fine. There were no errors, there was nothing. But either of those places, we could have got that, hey, either it didn't set the things right, or the traffic wasn't routing the way it was expected, or the health state had degraded. And we need to make sure that actually it's done both places. We too have the pre-test, pre-checks, and the post-checks that happen before calling the script is all good, because we can always have config drifts even between those. So that's one of the biggest one that we want to make sure it's there, and it's something that we've actually gone ahead and made sure all of our scripts do this at this point.
Cool. That's reassuring to hear. And then I wanted to ask about the failover, because it's not like Portal has never failed away from AFD before. This is something you've tested. This is something you've done before. But it seems like there wasn't really a regular rhythm of doing this. What can we do kind of culturally to make sure that this is something that we've not just done before, but it's something we're regularly good at?
Yes. So there are many things that we do a failover or a BCDR resiliency testing. This is one of those things we do, and it's not that the script wasn't tested, David, to your point, it was, but we need a better and a regular rhythm of doing it, because yes, we can have all of the automation, but there is no replacement for things which could have a drift or a change, and this is where we will make sure that we have a regular procedure. We have standard procedures of doing a lot of these BCDR validation and testing, and AFD failover is going to be added as part of it, which we do in our internal dogfood cannery environments and then test it out in slow stages in production as well. So that is also something that was a big learning, that we make sure that we on a much regular cadence than what we had done in the past.
Great. Yeah, well, not just testing, but we're going to be practicing that. And but one question that I think a lot of customers had was one around fault isolation. But Varun mentioned safe deployment. I think some people were surprised that when we're talking about this configuration update, that's being applied globally, not regionally. How do we think about the right way to kind of shard updates like that?
So just to add a little color to it, it wasn't that we just went from 0 to 100%. Even here, we applied safe practices where we updated our weighted traffic profiles from 10% to 20% to 50%. But yes, this was global config change, right? It wasn't 10% regional or 20% regional. So that's another biggest thing. And we have part of our repair item in the medium term to actually move to doing AFD updates more regionally. So even when we do, even in the regional one, we can go weighted percentage-wise, but then it's regional and it's not global. So that's definitely a little more work for us to do, but something that we've already started working on and would be trying to bring that in sooner.
Great. The last one I had on the list here was around kind of automated failovers and fallbacks. I wasn't sure if that was from the clients or if that's kind of you automating your failover from AFD. Can you talk to either?
Actually, that's a great one. We have both. We have our alerting and monitoring set up. So for some of the portal servers, we do have our incidents triggered, and there is an auto failover that we have implemented from AFD as well, which actually does work perfectly fine. But this is more on the client side fallback as well. So on the client side, we can implement some of our checks failed, where client-side caching could have helped protect from this, and we will actually go back and harden the client-side caching and client-side failback in case everything else failed, right? We still have this. There will be more protection from the client side as well, and that is also part of our procedure to make sure the impact can be reduced as much as we can.
Super, that's really interesting. I really like when you're practicing failovers, we often say in the team that building something is easy, maintaining it is hard, and there's drift as things change a little bit. It's really hard to keep everything current. It requires a huge amount of investment. So customers, I'm sure, will appreciate this. Varun, can we pivot over to you? When we think about learnings that we've shared with our customers, are there things that customers could have done to be more resilient? I mean, AFD clearly is critical path, not only internally, but externally as well. What are things that customers can do in order to be more resilient to AFD failures?
Yep. So similar to what Portal is doing, we do have guidance for third-party customers also on if they are running mission-critical workloads, how can they do failover from AFD to alternate stack, whether it's their origin or to some other CDN. There's guidance available online on that. The other thing is that when you do run into these kind of issues, exponential backoff retries always help. Like, for example, we had latency issues, we had some intermittent drops, but it was not a continuous down. So retries would have helped. Obviously, we don't want a retry storm also, so we want to make sure there is exponential backoff there.
And I guess similar question to you, Ruhi, is when the portal's having issues, I understand that customers, obviously they could use PowerShell, they could use CLI, like there are other ways of managing services. What levers are available to customers when the portal's giving them trouble?
Yes. So for example, even in this case, our management API layer wasn't impacted, which meant all of our other clients, this was portal specific, so other clients like CLI, PowerShell, Terraform, or we have the Azure mobile app. All of these clients were working and customers could have leveraged. On the Azure portal itself, based on, in this specific case, we had another domain, preview domain, which was available. So I would highly encourage, if customers are looking for, make sure that they're continuously looking for the monitoring updates coming from Azure status, because we will make sure if there's alternate domains that they can reach out to the portal. Those are listed out as well, and they can actually connect through that as well.
Cool. Sounds good to me. Thank you for running us through it. I've saved my last question for my co-host, Sammy. Since Sammy runs our incident comms team, we like to figure out, how did we do from a comms perspective? Did we keep customers up to date? Do we have any learnings on how we can improve there as well?
Yeah, so usually when I'm talking about communications in these types of things, I always focus on what we could have done better, and we'll speak about some of them small, some of them big. I think this is a time where we didn't show up at all for our customers. And to provide some context and kind of explain what happened, impact began just before 8 o'clock UTC. There was automated detection, as Varun spoke about. We did upgrade, we engaged multiple teams, but the signals that we got initially was the Azure Front Door was having issues, but we weren't sure about how widespread it was. And it took us essentially about 2 hours to post. We had broken queries to try and determine impact. The signals that we got that were coming in, we didn't correlate them in time. We didn't follow our procedures. We didn't kind of take a greater look. In the end, the signal became so overwhelming. Customers were complaining across multiple channels, internally, externally. And then it took us about 90 minutes to 2 hours to get a communication up, and that was just a banner. While we communicated up, we said the word capacity because we were talking about the Azure Front Door capacity. I think some customers misconstrued this as compute capacity, which wasn't the case as well, and so we want to be very careful with how we use that word. But I think overall, this is a time where we've gone away. We've had a lot of learning since then. Some of them have been very quick to implement. Some of them we need to do a better job of getting signals because we can't just rely on the noise in the bridge. The fog of war is a real thing. But essentially, I think if we were to go back in time, we missed an opportunity to post with the signals that we had. They were potent enough for us to sit down and say we have an issue. And so customers have every right to be kind of frustrated with the communications that came out. And absolutely, we've done a lot of kind of soul searching and a lot of change in our processes and some engineering to better amplify some of those signals when they come in.
Right. Yeah, I know a lot of that comes from a good place of us wanting to be accurate, wanting to just tell the targeted customers who were impacted. But ultimately, we need to know that, hey, if something big's happening, let's tell everybody, and then we'll figure that out later.
One of my colleagues always says, no matter how quickly the electricity company communicates you, you'll know when the lights go out before they do, which is always the case. And I don't ever think comms will be good enough for our customers, no matter how well we do. But we missed the bar by a long stretch here. So we definitely have some work to do.
Right. Got it. Good. Well, thank you for talking us through that. Thank you for watching this Azure Incident Retrospective.
At the scale of which our cloud operates at, incidents are inevitable.
Just as Microsoft is always learning and improving, we hope our customers and partners can learn from these too, and provide a lot of reliability guidance through the Azure well-architected framework.
To ensure that you get posted incident reviews after an outage and invites to join these live stream Q&A sessions, please ensure that you have Azure Service Health Alerts set up.
We really focused on being as transparent as possible and showing up and being accountable after these major incidents.
Whether it's an outage, a security, or a privacy event, Microsoft is investing heavily in these events to ensure that we earn, maintain, and at times rebuild your trust. Thanks for joining us.